on-off control system. Here's a block diagram from an on-off control system. We've got the reference or input going in here. So this is where you'd, for example, set the temperature that you want the room or the oven to be at. We've got a comparator, or we've got a switch or driver, which is going to be driving the output transducer, whatever device that may be. And then we've got the sensor, and what the sensor does, it produces a voltage which depends on the physical state of the transducer or the surroundings. And this is going to provide a feedback system going back to the comparator to be compared with the inputs. Remember that the output of a comparator is going to be plus or minus 13 volts. So the output transducer, which is going to be driven by that or controlled by that, is either going to be fully on or fully off. In the case of a heater, or if we connected a motor to the output, it's either going to be turning one way or it'll be turning the other way at full speed. Now, because we've always got the system being fully on or fully off, or fully one way, fully the other way, it means that even when we're close to the desired conditions, we're still running at full power, which means it's never going to settle in one state because it's going to be overshooting where we want to be, and this is known as hunting. So let's look at an example. An example I picked is an oven. So let's say that we've set on the dial, we've set a reference temperature here. So VREF, representing the temperature we want, is here, and let's say that the sensor is down here. So we're going to switch the oven on. It's going to take a little while. So because we've got the sensor is less than the reference, the drive signal is going to be high, which switches the heater on. It's going to take a little while for the heater to heat up itself, and then it's going to take a while for the heater to start heating the air. So it'll take a little bit of time before the temperature rises. And the temperature is going to rise so that the sensor is at the reference voltage. At this point, the drive signal is going to switch off, but the heater element is still hot, so it's going to continue heating the air for a little while, and then eventually the heater and the air will cool down. Once it reaches the reference, it's then going to be switched back on by the comparator and the switch. But again, it takes a little while to heat the element up and start heating the air again. And it continues. Again, it's going to overshoot because the heater is still pumping out heat, and so on. And we can see from this one that the on-off control system, it never settles at exactly the reference. It always oscillates around, and this is what we call hunting.